Here, these numbers still are Fibonacci sequence, right? They
Yeah. The
okay. And
Lucas
do you know how
numbers.
we can prove it?
I know they're called the Lucas numbers, but I don't know how to prove it. I just
Okay,
kind
so
of
we
like
want to
wrote them
prove
out.
that, for example, suppose that we define an equals f2n over fn, okay? And we want to prove why an plus 1, or an is equal to an minus 1 plus an minus 2, okay?
Okay.
We want to prove this. Try to prove this first on your own.
Okay.
One hint,
Yeah.
or want to keep trying?
Hint.
Okay, sure. So, look, when we have, for example, Fibonacci sequence, we want to find closed form of Fibonacci sequence, okay? Do you know how to find closed form of Fibonacci sequence?
How to do the golden ratio? No, not really.
Okay, let me tell you one way. Look, when you have an equation like this, that we don't have constant term 5 or something like that. For example, like what? For example, an is equal to 2an minus 1 plus an minus 3 plus, for example, an minus, for example, minus an minus 3an minus 4, okay? Consider the minimum one and consider this one is 1. So minus 3, this one is x because the index is 1 more than this, plus x. This one is 2x squared and this one is x cubed, okay? Okay, so if you want to write, for example, equation of this, polynomial of this, it will be what by this definition?
X squared equals x plus 1.
Exactly. And here x squared minus x plus
Why
1
is
is
it
0. This
why
is
is it
what?
minus 1? Why is it minus 1?
Oh, sorry. Fibonacci plus 1, so plus. So it's x squared minus x minus 1 is 0, right? So, for example, if you find 3 roots, if 3 roots are different, if 3 roots are different, then we can do what? Are different. Then we can say an is equal to c1 r1 cube plus, c1 r1 to the n plus c2 r2 to the n plus c3 r3 to the n. And c1, c2, c3 are constant, okay? And how we can find them? By plugging, for example, a1, a2, a3, 3 equation, 3 variables. So, can you tell me roots of this is what?
1 plus minus root 5 over 2. That is like the golden ratio or whatever, right?
Yes, so we agree we can say root 1 is 1, for example, plus root 5 over 2. Root 2 is 1 minus root 5 over 2, right? So suppose that we consider f1 is c1 r1 to the n plus c2 r2 to the n, okay? Try to find c1 and c2, okay?
Okay. Okay, I got 1 over root 5 is c1, or 1 over root 5 for the positive root, and negative 1 over root 5 for the negative root.
c1 is what? c2 is what?
1 over root 5, negative 1 over root 5.
Okay, let's check. We can easily find this by considering c1 plus c2 for f0, right? You know f0 is 0. 0, f1 is 1, so c1 r1 plus c2 r2 is 1. So c2 is minus c1, right?
Yeah.
So c1 r1 minus c1 r2 is 0. Now if you check this, it will be c1 r1 is what? 1 plus root 5 over 2 minus c1 1 minus root 5 over 2 is 0. So
Yeah.
1 and negative 1 will cancel each other out. So it will be c1 root 5. Sorry, it's not 0, it's 1. So it is 1, so it is 1 over 1. C1 1 over root 5 and that. Okay, so we can say Fn is 1 over root 5. 1 plus root 5 over 2 to the n minus 1 over root 5. 1 plus root 5 over 2 to the n, right?
Okay.
Okay, now use this to prove that
But
f
1 minus root. 1 minus, right? The second one just has to be minus.
1 minus, yes. We should consider this root. Now, let's consider this one an. Now prove that an is equal to an minus 1 plus an minus 2. Try to prove this. Now it's not hard, try.
Okay, I know a solution. So first I set 1 plus root 5 over 2 to variable a, and then 1 minus root 5 over 2 to variable b, or like a constant b, so it's simpler. And then I write the first term, which is an equals f2 at 2n over fn. So it's 1 over root 5 a to the 2n minus 1 over root 5 b to the 2n over 1 over root 5 a to the n minus 1 over root 5 b to the n. And then difference of squares is that's equal to a to the n plus b to the n.
Yes, here we can use variables r1 to the n, r2 to the n. An is equal to c1 r1 to the 2n minus c2 r2 to the 2n, right? Or instead of c1 c2, you can say, okay, c1 is equal to c, so it is c minus c r2 2 to the n, right? This one r2 to the n. We can cancel c from both numerator and denominator, so it will be r1 plus r2n, right?
Yeah.
Okay, now we want to prove what? We want to prove y r1 to the n plus r2 to the n is equal to r1 to the n minus 1 plus r2 to the n minus 1 plus r1 to the n minus 2 plus r2 to the n minus 2, right?
Yeah.
Okay, we know what? We know. Because of Fibonacci sequence, we know CR1 to the n minus CR2 to the n is equal to CR1 to the n minus 1 plus CR1 to the n minus 2 plus minus CR2 to the n minus 1 plus CR2 to the n minus 2, right?
Yeah.
And then we want to prove that R1 to the n is sum of these two, right? So if we want to prove this, directly we should prove R1 squared is equal to R1 plus 1.
Yeah, but we already did that because R1 is the solution to this quadratic.
Yes, x squared minus x minus 1 is 0. So because x squared minus x minus 1 is 0, so R1, R2 satisfies this, right? You can also calculate this. Also, R2 squared is R2 plus 1, so we prove this, right?
Yeah.